In this video, we're going to take a look at changing the base of a logarithm. Now, the reason that we have to worry about changing the base of a logarithm is that most calculators have a button like this one that we see here. And remember that when we're working with logarithms, if there's no base written, that's base 10. Well, the problem is that sometimes we have to figure out logarithms that are things other than base 10. So what I want to do is be able to change it so that I'm able to use my calculator and get an approximation of exactly what that logarithm would be. So we have a formula that allows us to do that, and it's simply this right here. So if we have the log with the base b of x, that's going to be equal to a log, and then these a's are another base. We could change it to any base that we want, and sometimes it might make sense to change it to another base, maybe like a base of 2, if we can make both the x and the b into something with the 2, if it's a power of 2, or if we just want to use our calculator, we can use the base 10. And I'm going to show some examples here of how we can make use of that. So, for this first one, what we want to do is go ahead and just feed it into that base change formula. So it's going to be the log of 13, so just the log part here, except now this is base 10, remember, over the log of 5. Okay, so remember, this is base 10. We don't have to write that. So now I can grab my calculator and get an approximation of what these values are. And when you do this with a calculator, what you want to do is, first of all, know which order you have to put the number in. Some calculators you have to put in the number, so I would put in 13 and then hit the log button. And some calculators you have to hit the log button and then put in 13. So make sure you understand what your calculator requires you to do. Okay, so then the calculator will give me a decimal approximation of this number, in this case 1.113. Now, you might say, well, how many decimals do you want? Well, the more decimals, the more accurate you'll be. So sometimes it asks for a particular accuracy in terms of tenths, hundredths, something like that. But I like to write a lot of times everything that shows up in the calculator screen, or just a reasonable sort of amount. So let's say that many decimal places. Now, one other thing I want you to make note of is, does this number make sense? Well, remember, this is the log base 10 of 13, so it says 10 to what power gives me 13? Well, I think it makes sense that it would be just over 1, because 10 to the first would be 1, so a little bit more than that, that'll get us up to 13. Then, do the same thing on the bottom here. We have the log of 5, so I want to use my calculator again to find out what that logarithm is. So it's 0.6989700. Okay. Then I do that division, and I should really use the squigglies here rather than the equal sign, because this is an approximation. It's approximately that. These are not exact values. It goes on and on and on forever. So then I just do that division to come up with what exactly that is. So I take that and just quickly punch those back into my calculator here, and we get 1 point, and it's approximate again, 1.59369264. Okay, so there's an approximation. Now let's just double check this quick and see if it makes sense, because remember, this means the log base 5 of 13 is 5 to what power gives me 13? Well, 5 squared would be 25, and 5 to the first would be 5, so this is somewhere between 1 and 2, and my answer of 1.59369264 that's between there. So that makes sense. So do that little double check just to make sure your answer is in the right neighborhood. Okay, let's try this next one here. For this one, again, a similar situation. We want to put the log, so just forget the base, make it the one that you want it to be. Again, typically base 10, so like so, and then the log of 8. Okay, need to figure out approximate values for those, so grab the calculator again, and the log of 21 is 1.3222219. Let's see, 1929. Okay, all over, and the log of 8, so it's going to be 0.903089986. Okay, well, let's do 87 because there's another 9 after that. Okay, so there are my approximations, and then I do that division. Again, the more decimals you keep, the more accurate your answer is going to be. So throw those back in here. Oops. And we get 1.464105.808. Okay? Now, again, double check. Does it make sense? Well, we have the log base 8 of 21. 8 to the first power would be 8, and 8 squared would be 8 times 8, which is 64. So we need to be somewhere between 1 and 2. 1.46. Yeah, that falls between there. So that makes sense. Alright, let's try another one right here. For this one, same kind of story. We're going to have the log of 30 over the log of 3. Figure out what those are going to be. So go ahead, use your calculator to do that. For the log of 30, I come up with 1.477121255 all over a log of 3, which is 0.477121254. Okay, and then do that division. So, oops, do that division, and we find, we pop those back into your calculator, and this is also a great time to, if you're not already familiar with them, the memory functions or the answer functions of your calculator, which would allow you to keep the entire decimal in your calculator and make use of it. Those are awfully handy. So do, if you're not sure how to use them, figure that out, and you can save yourself a lot of key punching. Okay, so we get 3.09590327. Okay, then let's think about that. Does that make sense? Well, 3 to the third power would be 27. So yeah, that's in that neighborhood. Just a titch over 3 gets us about 30. Yeah, that makes sense. Okay, and remember, we could also check by taking 3 to that power. That should get us 30 or thereabouts. If you check it that way, remember that because of the rounding, it might come out not exactly 30. It might be like 29.99994, something crazy. But understand that that happens because of the rounding. Now, let's try this last one, and I kind of put something that, a little trick in here, or a little secret for this one, to see how close we come out. So again, to change those bases, we'll go log of 27 over the log of 3. Log of 27, well, figure out what that is here. log, we get 1.43. 1.4313676 all over the log of 3. Hey, I just did that up there, so I can just go ahead and write that down here. 0.477121254. Then do that division, and if we do that divided by, we get 3. Hey, wait a minute. Well, 3 to the what power gets me 27? 3. Okay? So sometimes we might have something that we could do mentally. If we do it this way, we'll still end up in the right place. You got to be careful with your calculator. It might come out as something like 3.000014, depending on how many decimal places you kept. But you should notice, ooh, that one's really super close, and then that might jog the memory and say, oh, that's right, 3 to the third power gets me 27. So, changing the base of a logarithm, what I can do is use this formula right here to set it up and then use my calculator, because your calculator, that log key on your calculator, will only do base 10. So we have to make that conversion. Keep as many decimals as you possibly can, and off you go. Hope that was helpful. Keep working hard on your math.